Hello, today's topic is trigonometry. So let's start with the basics of trigonometry. Before starting this concept, we need to understand one thing which is called right angled triangles. What are right angled triangles? Basically, when you see a hypotenuse or a right angle at any of the corner of a triangle, that makes it a right angle. Right angle, opposite to right angle, we can see one side which is called hypotenuse, which is also called the longest side of this triangle. This is called base. This is called perpendicular. So whenever you see any right triangle, then only we are supposed to use the trigonometric things, right? So basically, if I want to write some side names, so this is A, this is B, and this is C. Here comes one more theory that is called as Pythagoras theorem. What is Pythagoras theorem? When your hypotenuse square is equal to the square of the rest of the two sides. That is a square plus b square. This is the formula or the rule or the theorem for finding the sides in a right triangle only. We are not talking about the scalene or isosceles triangle. We are only here talking about the right angle triangles. Later on, now let's try and understand what are the trigonometric ratios that we have here. So we have three ratios here. One is called sine, next is called cosine, and next is called tangent. Sine we can write as sine, cos, and tan. Okay. So what is the exact meaning of this? As the name itself says that we are talking about the ratios. Ratios are not having any units. So we are not supposed to write any unit for it, whether it is centimeter, meter, or anything. We are not supposed to write those units because ratios are fractional things, and fraction does not have any unit in your solution. First thing is this. Second thing is when we talk about this, so we can learn this by using one trick that is called SOHCAHTOA. So what is SOHCAHTOA exactly? So let's come back to the triangle thing again. Suppose I'm drawing a right triangle like this, and I know that the opposite to right angle is the hypotenuse, which is lying here, and the lower one, suppose we are finding some angle here. If I am taking this as my theta, theta here stands for the unknown angle or the known angle, right? So if you want to find this theta, right, you need to label it first. That's also called labeling of triangle. In labeling of triangle, basically, when wherever your theta lies, that line is called adjacent. Opposite to this theta thing is this, which is called opposite, and this opposite to 90 is hypotenuse, right? Suppose if I'm making one more triangle and I am putting my theta on this side now, and my 90 degrees lies here. So that means this opposite to 90 is hypotenuse, which is the same position again, right? But my theta got changed this time. Theta is lying here. So that means this part or this side is my adjacent and this one is my opposite. I hope the labeling thing is clear to you guys. Now I'm coming back to the same thing which was SOHCAHTOA. SOHCAHTOA. Now again I'm rewriting these ratios. That means that your sine theta is the ratio that you're finding in respect to the angle. So the theta is equal to the opposite over hypotenuse, right? So that means we are writing sine as opposite over hypotenuse. Similarly, your cos theta is adjacent over hypotenuse. And your tan theta is opposite over adjacent. That's how we can easily remember these things by learning the labeling and then the SOHCAHTOA. After this, let's try some questions by which we can get a better understanding how to use these formulas or how we can apply to certain things and we can get the answers easily, right? So let's try one question that says if I'm making a right angle triangle like this is my 90 degrees, this is x meters, this is 41 degrees, this one is 7.8 meters. So how do I am supposed to find this x now? So as I told you, first thing is that you're going to label all of these, right? So every time, whenever you're using the trigonometric ratios, that please label it, right? Without labeling, you may get confused, right? So I know that this is the opposite, so this is my hypotenuse, but I'm not mentioning that hypotenuse. Reason being, I don't need that for now, right? This is automatically understood that this is my theta right here, okay? And on theta, theta is lying on this line, that means this line is my adjacent. And opposite to this is this. This is my opposite, right? So I am writing one thing here, which is so ka toa. And now you can check where you are seeing this opposite and adjacent thing. Opposite and adjacent are lying in tan. So I am using tan theta equals to opposite over adjacent. And now tan theta's value is 41 degrees. Opposite is 7.8 and adjacent is x, right? Now we can do the normal calculation by you can cross multiply it. So x comes out to be 7.8 times divided by tan 41 degrees. If you plug it in your calculator, that will give you a certain answer, but that will be an approximation. So you are always supposed to mark your answers like this with this sign. This is actually the sign of approximation. And if you plug it in your calculator, that will give you some value as 8.97. I'm just taking it to two decimal places because many times in question they are going to write it as write your answer in 2dp. 2dp stands for two decimal places, or they can write it in three decimal places. So you need to round it off and then finalize your answer with an approximation sign. That is a must thing. You always need to write that thing. So that's your answer. That's how you are supposed to solve it in exam. Let's take some more example. Let's try this one. If I am marking a triangle like this, and this is 2.67 kilometers, this is angle theta, and this is 5.92 kilometers. So how do I solve it for theta? Here you are supposed to find the value of theta. And I can also specify that whether you can find your answer in three significant figures or DPs maybe. But here I'm using a different word which is three significant figures. Okay. Let's just solve it first, then I'll tell you what is three significant figure means. So what was the first thing? First step was we need to label this triangle. So opposite to this 90-degree, I can see that this is my hypotenuse and theta is lying on this line, right? That means this is my adjacent, right? Now you are supposed to write the same thing. So ka toa. So hypotenuse and adjacent. Hypotenuse, adjacent are lying in cos. So we'll use the cos rule here. Cos theta is equal to adjacent value is 2.67 over 5.92. Right? Now again we are going to cross multiply it, but your cos, if you're shifting your any trigonometric ratio to right side, then you're supposed to take the inverse of it. Inverse is cos inverse. This is 2.67 over 5.92. That's how we write it. Now my cos answer will come out to be approximately 63.2 degrees. I have written this answer in three places, right? Whether it is before decimal, after decimal, that doesn't matter. We need three significant figures for our answer. Three significant figures here means that you should have proper three numbers here, right? We need to round it off and give our answers in three significant figures. And mostly in the trigonometric ratios or whenever we are solving the trigonometry, you're always supposed to write your answer in three significant figures, whether it is a part of true bearing, whether it is a part of 3D, anything. That is the but obvious thing here that you need to write. And many international exams also refer to the same thing. So always remember to write your solutions in three significant figures. This was all about the second example. And this is how you can find the rest of the ratios, rest of the values, or rest of the things, whatever the question is asking you. So I told you a few things that first of all, label your triangle before solving this, right? Just check the trigonometric ratio. Just check which ratio is applicable. And third point is that you always write your answer in three significant figures. That is a must thing. That is how you can easily solve the trigonometric triangles. Now come to the application part in trigonometry. So when I say applications of trigonometry, applications are basically that thing that where exactly we are using the trigo. Application, maybe the real life examples are there, or what exactly you're finding that ways as well, right? So it is exactly the same where you guys are using this. Where do we use this trigo? So first thing, I'm just giving you a quick review of it that firstly I'm telling you that we are using it in angle of elevation and depression things. Second thing we use in properties of triangles. Triangles, maybe it is isosceles or equilateral. All of those triangles will work here. And maybe it could be a part of quadrilaterals as well. We have different type of quadrilaterals, so maybe we can use that this in that as well. Third thing is that circles and tangents. There are many parts where we can easily use the trigonometry to find the real and quick solutions. Next is true bearing. True bearing is going to be a very important part of your syllabus. Fifth could be three-dimensional shapes. So let's take one by one all of these, right? Firstly, today I'm going to start with the applications of trigonometry with angle of elevation and angle of depression. What is exactly the angle of elevation and depression is? Firstly, we'll take one line of sight. I'm calling this as line of sight. So if I'm seeing something in the sky from here, suppose an observer is lying here. Observer could be anybody. We are just taking a simple example. Observer is lying here and I am seeing some bird here in the sky. So if you are seeing that bird in the sky, so the angle that you are making with the ground is called angle of elevation. Elevation basically means you're elevating something. You're going upwards from your line of sight. So this is elevation. And suppose you are on a top of a building. This is the ground level. And you're top of a building. Your observer is lying here. And you're seeing some car, right? I'm sorry, I'm making a very bad figure here. But let's take that this is a car moving here and you're watching it from here. So from a top of a building, you're staring downwards or you're gazing down, right? So that angle, suppose your line of sight is lying here, right? This is here your line of sight now. Line of sight is basically where you can easily horizontally taking your eye. Okay, so this angle is basically the angle of depression that you're moving it down, right? And here the same angle as this and this line are parallel. Ground level and line of sights are parallel. Then we can easily say that this angle here is angle of depression. So both of these are equally important, but they are same. We are only talking about the line of sight in both of these directions. If we are seeing it upwards, then it is, if I want to make it in one go, so this is my line of sight. If it is going upwards, then this is angle of elevation. And if I'm seeing something here, so this angle movement is angle of depression. So it's as simple as that. Okay, so this is the same thing that we are checking it from both the directions. Now let's try and understand with some example. So let's just take an example of angle of elevation and depression. I'm just copying an image for you guys, and for a better view, I'm extending this picture. I hope you can see this properly. So this is a very good question and a good example to understand trigonometry in a better way. So let's try it and read it. The angle between the tangent from a point P to a circle and the line from the P to the center of the circle is 27 degrees. So this is not going to be a very difficult one to understand. Just have a little understanding. So I am drawing a circle here like this, and suppose this is the center of the circle, and if I want to mark the tangent to a circle, tangent is lying here. Okay, and this is the center of the circle. I'm moving it here, and I'm just touching this point to this. Let's now understand it and read it one more time. The angle between the tangent from the point P, from the point P is this, to a circle. So this is the tangent, and the line from P to the circle, to the center of the circle, is 27 degrees. That means they're talking about this angle is 27 degrees. Determine the length of the line from P to the center of the circle of radius 3 centimeters. So this part is 3 centimeters. So what exactly we are supposed to find? We are supposed to find baseline. Baseline means from the center, the length of the line from P to the center of the circle. This, this part, this whole line we are talking about. So now we got the question, now we labeled it. Everything is there in the figure. You don't require the question now. Now let's jump on to how to solve this part. So let's understand it. What did I told you guys? I told you to label the triangle first. So if it is 90, this is my hypotenuse. This is my theta angle, right? And this is my opposite. Okay, now I'm writing so contour. So basically opposite and hypotenuse. This. So we are going to use here sine 27 degrees is equal to 3 over x. Now do the cross multiplication. X will be equals to 3 over sine 27 degrees. If you plug it in your calculator, that is going to give you an approximate answer. So the approximate answer, I told you a mark to mark here, which is this approximation sign, and the answer is 6.61 centimeters. As the unit here is centimeters, so you are going to mark the same unit here. So that is what my answer is. I hope this makes some sense. Now, let's take one more question. Let's just take another example. And now let's try it. So the figure is already given in the question. We just need to label this thing. A ladder 4.1 meter in length rests against a vertical wall. Vertical wall is this one. Reaches 3.5 meter top. So that means this line is 3.5 meter up to the top level of the ground, and find the angle of the ladder that meets with the ground. So that means if it is vertical, it is automatically known that this angle is 90 degree to us. Okay, and this measurement is 4.1. That means the length of the ladder is also given to you guys, this one, and the angle we need to find in this. So what do you mean by which angle we are talking about? We are talking about this angle. The angle the ladder makes with the ground. So this is my ground level and this is the angle that we are making with the ground. So this is my angle theta, right? So let's just label this thing first. This is opposite to this. This is opposite and opposite to this is hypotenuse. So the length of the height ladder is hypotenuse. Now again SOHCAHTOA. I'll always try and again repeat the same thing that always label the triangle, then please mark SOHCAHTOA and check which trigonometric ratio is applicable here. So here opposite and hypotenuse. So that means we are going to take sine here. I'm talking about the first part. So sine theta is equals to 3.5 over 4.1, right? That's a very straightforward question. Now we have to shift my sine to right side. So I told you what we exactly do in this. We'll take sine inverse 3.5 over 4.1. You can directly substitute this in your calculator, which will give you some approximate solution. And I told you the approximation thing should be written like this at 58.6 degrees. That's your theta angle. Now we are coming to the B part. B part says the distance from the foot of the ladder to the wall using trigonometry. That means we are talking about this measurement. So for this, we can use another thing. So this was opposite, this was adjacent now, right? So now we can use adjacent hypotenuse or adjacent opposite. So I am okay to take this adjacent and hypotenuse. So I'll be using cos. I know the angle, which is 58.6 degrees, is equals to adjacent is x and hypotenuse is 4.1. So x comes out to be 4.1 times cos 58.6 degrees. That will approximately give you 2.14 and that will be in meters. So this is your required solution for part B. It is up to you guys. There is one more technique to solve this question. I'm telling you this that one as well. So I'm just drawing a simple triangle here. This is 90 degrees. We need to find this measurement and this is 3.5. This is 4.1 meter. And here also I can use Pythagoras. If you can see, you already have three measurements here, out of which you already know two. If you want to find the third one, you can use Pythagoras theorem. As we know that our calculator is allowed, so it is quite easier for us to solve. C square is equal to A square plus B square. So that means 4.1 square is equals to 3.5 square plus x square. So x square could be written as 4.1 square minus 3.5 square. If you are not using your calculator, you can directly do it by using a square minus b square rule that says a plus b and a minus b. This is algebraic rule which you also can follow here. So that rule says your x square thing, I'm rewriting this, your x square will be 4.1 plus 3.5 and 4.1 minus 3.5. That is going to give you 7.6 times. If you subtract it, this is zero point 0.6. And if you guys are multiplying it, this is going to give you 4.56. And You can shift your square root to this side to easily get your answer, which is going to give you 2.14. This is again an approximate answer. Both will give you the solutions, but it is depending on you which method you want to follow. Both are correct. So there are many ways to solve one single question. It is one of those. It's up to you again. What method you understand, which way you understand, what do you want to execute in the exam, and which one is more or less time consuming in the exam. So you always choose the easier method to, attain your answer easily. Don't go by scratching it all through because there is no point to write it because there is also a time management thing as well. Sometime also we'll discuss about the same thing. That's the end for today. Thanks a lot. Take care.